All right, might as well get started. So the last video slash stream, we ended at updating the power supply schematic of the design to incorporate the connector, the uh, blocking diode, some status LEDs, and test points. So we're going to move forward and do the RS-45, kind of touch up on it, clean it up a little bit, add the connector, the external connector. Before I do that, what I will do is copy that. There's a reason for it. Because a lot of manufacturers, okay, have a scheme when they do the part numbers. So, the manufacturer part number that would be for Molex. That's a series, and that is the part within that series. Pardon me. So, to the schematics. So I'm going to say at this point in time, we're done with the schematic for the power supplies. We're done. We've got everything we want. So let's go to RS-45. So the one thing I want to go and throw in here is the connector for the A and the B and a shield. Uh, Even though you only want one end of any shield actually tied into place on a bus like a RS-45 to prevent ground loops. Um, you still want to be able to give that point in case there's not one at like a peripheral or a source or like a controller. So like if we tie into like say a PLC or something over RS-45, that way we at least give a possible ground point for the shield, even if it's not provided on the other side. So we're just going to go with uh, a three circuit connector. So about that part numbering, so we're going to paste the part number up here again, but we're going to change that to a 3. And bam, 3 circuit. So we get the exact same part. It's going to match the 2-pin version, the 2-circuit version, but it's the 3-circuit version. All we had to do is change, bam, that. And so if you want to know what all available, you could do this. So I have 2-circuit all the way up to, it looks like a 16-circuit in that same series. Makes it real easy sometimes to find parts once you kind of learn how a manufacturer does their part numbering schema. Now, again, there's no 3D model or footprint. So let's go see if our DigiKey has it under their models. Ultra Librarian seems to have all of them. Beautiful, because we really, not like we need the symbol, but we'll use it. But we'll get the 3D model, the step file, and the footprint. We're going to download it for KiCad version 6 Plus. It's going to download the zip file. Wait for that to happen. All right, I'll close that here. Downloads. Extract all. Lather, and it's going to be more lather, rinse, repeat. Again, we slowly will get faster as we go. All right, so here we go back to the footprints. Okay, so let's go to File, Import Footprint. Open. Change that to CN. All right. And then let's change pin 1 to a square rectangular. All right. Now we're going to save it, but we're going to here 3 under connectors. And then we're going to File, Properties, and we're going to bring in the step file. Jeez Louise. Says offset. Bam. All right, let's see. All right. That looks pretty darn good. Okay on that one. We're going to save it. All right. So now let's go back to the symbol editor. So we have the part number. We're going to file. We're going to go and import the symbol. Open. We're going to rename it KP. All right. I just stopped moving all this stuff. Okay, let's see if it matches. It does not. All right. So, let's clean this up. Let's get rid of this. Go through, we'll clean all this stuff up. Here we go. All right. Now, let's see here. Now, it's this. All right. Let's just go ahead. Clean this up. Probably been Control Z, thank you. All right. Try to get things aligned so they kind of match a little bit better. All right. A little oversized, but we'll deal with it. Okay. File, symbol properties, CN, value there is fine, footprint, nope. We got to go to connectors, 3, okay. Okay. Gotta give this guy a little bit more room here. One. All right. And because we want to just stay consistent, even though we're not going to put anything in there, we don't care. Data sheet we ignore. Description. So what we're going to do is we're going to hit OK here. Go ahead and save that. Go here. Files and properties. I forgot to change that. That's fine. We're going to copy this because it's pretty much the exact same stuff. Save that. Go back to here. Properties. All right. So description. So it's going to be just 3 circuit. That's primarily the difference. We'll double check 300 volts at 18 amps. I'm willing to bet you 300 volts, 15 amps. Okay. That's an easy fix. Not a big deal. 15 amp. All right. Manufacturer 1 is Molex. And our part number is this guy. Mausa. Their part number and then their cost. 52 and 471. All right. And their part number. Bam. We're not going to close that yet because we got to go here and do the usual and add it to Odo. But we also have to add the other field that I almost forgot about. The mate field. I actually kind of forgot about that. So instead of a valve field, it's kind of a mate field for connectors like this. We'll get that here in a minute. Let's get in Odo and get this going here. Okay, copy that. And it's 2 scenes. Category, connectors. Copy this guy. All right, purchase. All right, and we're going to save that. Connect those. All right. So what we're going to do is we're going to go back into the schematic. I think the partner would be the same. But let's go back up to the power supplies. Let's grab its mate. Because what we can do then here is go here. And the same applies here. We can go, bam, three circuits. So right there, that's its 3-circuit mate. Copy that. Come down back to KiCad to the connector, mate, bam, visible. Okay, okay. All right, I'm gonna save that. So we need to go to Odo and enter its mate into here. So it is a pluggable terminal block. So what we're going to do, we're going to copy that first. I'm going to throw it in here. 3-circuit. This connector. What's your cost? $320. Good thing. So it's unfortunately sad that things like this are what's going to really increase the cost. But I would prefer to pay a little bit more for quality and to get what I really want with a product, with the design, than to just settle for something just to save a buck or two. And this is what I envision my product to be. So this is the direction I want to go with it. And again, you get quantity breaks as you start buying, more of your product, more of the products. So let's see here, back to here. It's going to be, let's copy that. We got that. Let's make sure I have that copied. So it's going to be KP. Okay. Cost is $320. I hate how you do that. Purchase Mausa. All right, so now we've got that and its mate added to Odo. Let's make sure we don't have to save it. Okay, okay. This is messy here, but I don't care because it doesn't show, and we can fix it in schematic to make it look prettier. So we're going back to the RS-45. Go to connectors. Here's the 3-pin. So let's see here. Since we're not going to be carrying A and B over now, we don't need the ports. So what we'll do, kind of set you up here. Let's drag you down. All right, so boom. All right. Loading J jumper, which makes sense because that is a jumper. So CN1. So that is that. It won't match the power supplies because it's got J. Let's see if we can update symbol. Reference. Update. Close. All right. All right. I made the mess. Let's clean it up. All right. Save that. Back to the RS-45. We'll just leave that where it is. Doesn't hurt anything. Did I not have that visible name? Let's go and double check that. I keep hitting the wrong button. All right, files, properties, meet, show name. Save it. Go back to here. Update symbol. Update. Close. There we go. All right. So, what we can do if we really are interested, which wouldn't hurt, we're going to throw in a couple of test points. Let's see here. We'll throw one in here. Here, just because it's schematically easier to do it. Test points on the A and B line. So if we have to throw a scope on it or something. Do I want to throw test points on these guys? You know what? Let's go ahead and do that. Because the board doesn't have to be super small, and again, we have top and bottom that we can populate. Test points are generally never a bad idea to have. Stop. There we go. That doesn't really need to be visible, but I'm not going to mess with it. It's fine. Plus, having more test points will help during any of the qualification testing that we have to do. You're only doing yourself a favor by throwing test points in. Even if we don't populate them with the keystone test points, we just leave the solder points there for fly wires. If we have to use them, it's still going to be helpful. There we go. So let's take you up to RX, the direction, DX. So now we got some test points in here. All right. It'd be a lot easier to probe if we need to check for things with, again, with the scope probe than trying to probe the chip directly. We've already got a test point. You know what? It wouldn't hurt. Let's throw another test point in. So what we're going to do is let's go ahead. All right. That way there's a ground connection close to those connections. That way it's easy to hit a ground reference if we're trying to probe the logic of any of those at the 485. The lines going to the microcontroller. That way it's just easier in the long run. For, I guess, lack of a better term, niceness, we can kind of drag this over a little bit, kind of center it a little bit more. So that should take care of the RS-45 interface. Not too bad. We have our connector. So what we're going to do, we're going to copy that because we're going to need that. All right. That all looks good. We got some test points in there. We've got our RS-45 connector there. We've got test points on the interface chip. All right. We got our TVS diode. Okay. And our terminator resistor here. All right. Limit switches. So. Now there's so many things we can do here. All right. Let's kind of move these guys over a little bit. Clean this up if we need to. Not a big deal. So we have 1, 2, 3 plus a common, so we're going to need a 4-pin connector. And what's cool is Molex makes a 4-pin connector. 4 circuit. All right. So let's see if we can get that. If we can get the model. 4 pause. I hope so. It'll make my life easier. Looks like we can. Beautiful. Beautiful. KiCad step file download. Make sure a 4-pin connector is what we want. Yeah. Input, input, input. 3 inputs, 1 common. And we're going to do something a little differently. We're going to add some stuff to the circuits here in a minute. I just want to go ahead and get the connector settled in before we make some decisions here. All right. So let's go extract the 4-pin. And let's lather, rinse, repeat. Get that little fella added. File, import footprint. All right. Change that. Change that from a rectangular, from circular to rectangular. Four 39522-004 under connectors. Okay. Properties, 3D models. Same song and dance as the last time. Just kind of get this squiggled over so it looks good enough. That looks fine to me. Save that. And then back to our connectors. Woo! File, import symbol. Actually, we almost don't need to import it because we just have to add another pin. So what we're going to do is we're going to take the 03, we're going to duplicate it, we're going to rename it 04, file, symbol properties. We're going to go through here and clean this all up. Oops, home. That more likely is going to be their part number. Let's double check. Oh, it's non-stocked. Ooh, we're going to need to find a vendor for this. All right, it's non-stocked. Looks like, wow. All right. So, all right. I didn't even see that. That was my stupidity. And this is where you run into these problems. Let's look here. Same sky. CUI devices. Turn block, header, 4 position, 5mm. It's pretty much the exact same part. 10 out 400 volts. Wow. All right. All right. So this is going to hurt a little bit. Non-stocked, and you have to buy MOQ 6480. This is where things are going to get a little crazy because we have a decision to make. This is where things are going to get messed up. So we could go ahead and go with the same sky. Let's see if Mauser has these. Huh, surprisingly, they do. So they have the 4-pin. 4-position 5mm PCB mount. It's pretty much the exact same part. Is there? I want to look to see if there's a mate. 12 to 28 AWG pluggable, right angle, 4-position. And the prices are a little bit better. So we have a decision. I think we can go ahead and go with this one. So one of the things we can do is um, backtrack and use the same Sky version, like get the 2 pin and the 3 pin, and swap out the connectors used on the um, so let's find out. Let's see if they make a 2 and a 3. So put this in a new tab. So usually if they're part numbers, so we're going to see if it's a 2. All right, 2BE, they have them in stock. All right, let's see if they have the 3 version. And they have the 3 position in stock. That's just great because Same Sky, formerly CUI, it does pretty much the same. So here's the connector for the actual terminal. It's 2 position. Have them in stock, and their price, not to be a little bit rude, they're a little bit better than Molex. This should be the 3. So our pricing can be a little bit better for the board, and we get exactly the same thing we want. All right. So maybe what I'll do is I'll leave these up and we'll go ahead and get the 4 position. We'll go ahead and select the 4 position. I know they have the, but I want to see if we can get it from DigiKey. If we can, symbol footprint, 3D model. Perfect. The symbol, and we'll copy and paste the symbol. Well, I mainly need the footprint and a 3D model. Step file, KiCad, V6 and later. So what I'll do is instead of wasting time, I will go through off camera, off stream, and replace the 3 pin and the 2 pin with the CUI version. And that'll just be better off in the long run. But we'll go ahead and have to create an account. I'll do that off screen too. Not a problem. TBR. All right. Extract all. Perfect. It's got the symbol and the model, but I only need the footprint and the step file. So we're doing the 4 pin, the 4 terminal, 4 circuit. So let's go into here into the footprint. All right, file. We're going to import a footprint. Now, chances are the Molex footprints will work. I don't like taking chances with things like that, though, because there's always the chance that it won't. We're going to open that. Reference. We're going to go to CN. Okay. Pad 1's already. All right. Let's see here. Let's just use their part number for the footprint. All right. It's going to be connectors. Okay. We're going to file, properties, add the footprint model. Oh, jeez. Okay. Yes. Let's play the. Finally, there we go. Woo! Oh my god, the whole thing needs to be fixed. All right. Now I can look at the data sheet. What is, should tell me 4 millimeters. But representing that is wrong. Again. 3.8. Good enough for government standards. Yeah, I'll definitely go through off camera and stream and 10 point. There we go. Save that. All right. Let's save that. So, since we're going to a 4-pin for this guy, you know what? We'll just copy because we have a lot of the stuff here. Duplicate it. I'm going to rename it. KP. Okay. Copy that so we can go into the properties. LV. Connectors. Hello. Oh, KaiCad's mad at me for some reason now. What in the world is wrong with you, KaiCad? Oh, symbol editor. Why are you mad? All right, file, symbol properties. All right. Oh, you little bugger, you little bugger. KaiCad, you just made me upset. So we're gonna duplicate that again. Rename it. We're gonna go and save it before it gets upset. Symbol properties. Value. Control V. That. Okay. I mean, let's see here. I think these are going to be blue. Yep, blue. So one of the problems with Odo is you can't have duplicate product descriptions. So what we're going to do, um, if I ever add this Molex to um, Odo, we're going to add blue to the description because that's the color. I think it's one word. Same sky. Nope, 2 words. My bad. Same sky. Going through, clean all this stuff up. Manufacturer part number. Mauser. $62 and $246. All right, so before we get too far, this is its mate. All right. Okay. Back to Odo. Blam, blam. 62. 8. Tags, category, connectors, reference. Purchase. Mauser. That's one. All right. Upload. All right. So again, we're going to need to copy this. So that will actually be easier. Connectors. So it's going to be blue plastic. That way Odo doesn't get too mad. Let's double check the specs on that guy. It's going to be... very confusing. We're going to just go 10 amp at 300 volts. Oh, this is going to be 4 circuit. I am messing with myself. Let's see, this is 10 amp, 300 volts. Oh, stop it. Stop it. I mean, 10 amps is still formidable. And nope. 28 to 12. 28 AWG to 12 AWG. Cost is $1.38, which actually isn't that bad. 28. Yeah, let's. All right. Purchase. Mauser. All right. So we've got it in there. We've got the mate. Let me make sure that I've got that into the KiCad. Mate, yes I do, yes I do. Bam, bam, bam. Okay, okay. Save that. 4 pins. Symbol looks okay. 4 connectors. All right. Oh, okay. I screwed something up. Let's fix it. File properties. Why are you not finding the footprint? Why were you giving me error that your footprint? Okay, let's see why KiCad's a little upset. Maybe it didn't copy it for some reason. No, right there it is. File, footprint properties. We have that. Oh, save it. Okay, KiCad, why are you upset? No. Yeah, that's fine. Why are you upset? Connectors. Oh, wait a minute. Um, this is new. Okay, I want to solve that problem. Oh, keywords. Maybe I need to. Maybe it needs to be there too. Save that. File. Okay. Oh. Default. We will solve that problem later. All right. Okay. I don't know why it's not showing the footprint. All I say it's not found. All right. Well, we will solve that problem later. It might fix when I close KiCad and reload it because it did do something weird. So we are going to go ahead and start. Hello. Start plumbing these guys in. There we go. That way, it just kind of tidies it up a little bit. See if I can pull this in a little bit. All right. All right. So now we want to kind of figure out about our limit. So we have a common there. So we have a limit common. We know we're going to tie it to pin 4 here. But one of the things I want to think about is, do we want to throw a jumper block in here to allow us to also be able to tie it to an internal ground or internal positive. Um, like say internal 24 volts or internal ground. That way, we could feed the device another way. Or if we want to just leave it like this, to where uh, you could just tie it off of the. So how do I want to do that? Normally, if I were making a self-contained device that I would not really care, um, if I didn't really want to run it to uh, an external common, I would put this to ground and make this a positive. So let's go ahead and throw a 2-pin connector in here. All right, let's see what we got. So we're going to throw this in here. And I'm going to show you what we're going to do with it. All right. So what we're going to do is we're going to pull off of here. Pardon me. Pull off to here. We're going to tie it here. We're going to copy ground. Then we're going to give a net label. Be limit under LMT underscore C. Bam, and we're going to tie that to this filler right here. So now, electrically, that should tie to the limit common. And what this jumper will enable us to do is, if we want to wire this up differently, where it supplies its own, it comes off 24 volts to feed through like a switch. We have an internal grounding, or this will allow us to tie the common here to, like, say, a PLC common, like a positive. Let's say if we've got a PLC with a syncing input, we can tie it in such a way that we can tie the common to positive, and then each of these to the associated contact points. Let's see here, the Y outputs on the PLC itself. Since these are AC input opto isolators, it technically doesn't matter what size positive and negative, so that's cool. Now, so what I'm going to do, I'm going to pull these guys out. Yes, we're going to throw test points in. Because right now, technically, we are not constrained on space for the size of our PCB. This is our product, our design. We can make the PCB as large or as small as we want. So if I have to add extra room because of test points, let's add extra room because of test points. All right. All right, so we have test points on the limit switches so we can check their outputs. We can throw test points on the inputs if we really wanted to. But the good thing is that's a terminal block. We can always just direct wire into it if we really wanted to. And yes, before I forget, we're going to throw another test point in here. For ground. Again, we always want at least one ground connection. that we can tie into that can be shared amongst the inputs. So that should work there. Okay, so let's see where we are with this. So we have our opto isolated inputs, our pull down. And honestly, you can wire these up any way you want. You can have them limit switches. You can have them because you can program the ESP to look for a low or a high. So if you want them to be active low, you can always set that up that way, or an active high. It's depending on how you want to program the you'll want to program the ESP32 in the end. That's why this whole idea of this project, kind of like a development kit, like a playground, without having to constantly set this thing up on a breadboard. It gets annoying. Long run. So here we have this guy. So I have a couple more minutes, and I'm going to show you the beauty of the way we set this up. We're going to copy all of this because our control inputs are identical. And the great thing is we can just do this. All right. And we're going to save that. We're going to go to ESP32. So it's just input 1, 2, and 3. Input 1. And input 3. And then input common. And this guy right here. Ah, okay, that makes things a little bit easier. And bam! Now we have our inputs. Everything was copy and pasted. So we now have our inputs duplicated just like our limit switches, which are just other inputs, and we can do the exact same thing here. Opto isolators, AC input. They can be common, so you can tie them to a PLC, or here if you really want to set this up to be defined to set the input common to the internal ground. That way you can just pass 24 volts through. I'm hoping that once we get this built, maybe we can run through some examples of how it can be used. Maybe some different settings, maybe even tied to a PLC. Who knows? We'll see. So that does it for catching up on where we are with the schematic so far. So we've got our power supplies plumbed in. All things figured out there. Our 45 interface kind of plumbed in, figured out there. Our limit switches and our control inputs. So the next things we'll have to address is the stepper driver, our basic UART serial interface, which we might be able to throw on this page, or I typically like to throw an ancillary. We'll need to do our USB UART bridge programming. We'll have to do a sheet devoted to that. And then, like the fan, because we've chosen a fan that we can control via TAC and read its. We can read the TAC and control the PWM values. It's just fun. I already have a library I wrote for a header source set up for TAC controllable fan or a PWM controllable fan for another project, so we'll just use it. Won't write one from scratch. We might have to write a motor control from scratch. We'll see. PWM is nice. but we might actually see about designing our own kind of step control. Uh, we'll figure all that out as we go. Again, this is going to be a playground, a development kit that you can program and work around that's already plumbed up and ready to go for stepper motor with kind of a robust set of input features, especially the RS-45 and even standard UART. And you'd be able to hook it up to a PLC to say, okay, here's input, go, uh, and then feedback from limit switches, etc. So I think that's where we're gonna end today's video, today's stream. This covers quite a bit, and we'll be jumping into again the UART interface, the stepper motor driver, and some of the other ancillary things to kind of get things cleaned up. Before I go, I'm going to slow down the upload of videos to YouTube. Primarily because one is I think I'm going to just go to like a 1 a week kind of schedule for now, because I am planning to maybe do other videos in the future, maybe other projects, maybe Circuit Studio. I'll talk with my current employer. Who knows? Maybe we can do some stuff on Altium Designer. I don't own that software. My employer pays for it. So if they're okay with it, maybe we can do some stuff with Altium Designer. But definitely Circuit Studio. Maybe I can do some tutorial vids, some real quick design videos in there. That's my preferred package for what I'm doing. KiCad has been pretty nice so far. This has been pretty fun, pretty enjoyable. I'm hoping others are learning how to use it. I mean, I'm not an expert with it. I'm learning it as I go. This is the first time I've used it for this video series, but it only helped in the long run to know more of these software packages to help better support my customers and our customers at Sanctuary Software Studio. So, hope you had fun. I do want to clarify that another reason I'm going to slow down the upload to YouTube is there's going to be a lag in time when it comes time to actually order materials, order the boards and all the components to actually build the prototypes and start testing. We're looking at least week and a half, maybe 2 weeks before everything arrives, based on turnaround time, shipping times, and everything. And this will at least let me stockpile some videos so that at least we'll have some content uploaded. Thank you. Have a nice afternoon, and I will at least stream and record tomorrow. And we'll go from there. Have a great evening. Great afternoon.